I remember I was teaching a class once, and I was working in my lab environment, and I was switching between servers as I was demonstrating things, going to server 1, going to server 2, using RDP to go back and forth. Didn't think much of it. After class one day, I had a student come up to me and say, "Hey, I noticed that when you're opening a remote desktop connection, you are using the names of the servers to switch between servers rather than the IP address." And he wanted to know how that worked. And I was a little caught off guard because in my mind, this is like super basic 101 stuff that everybody in IT knows. But it made me realize that DNS is kind of one of those things that maybe isn't super well understood, especially for somebody new who is first getting into the career and first learning about things. So I wanted to make this video today to go over just the basics of DNS, like really simple how it works. And a lot of content that I've seen in the past as I've studied for certifications kind of focuses on the Microsoft side of things. You know, these are the different record types. This is the different zone types you can have on a server. These are how you do different configurations. I'm going to avoid some of that more detailed work, and I actually want to take a step back and look at it from a practical standpoint. Like, DNS is constantly working anytime you're on a computer. So I wanted to kind of go over, in a high level, how exactly everything is functioning. I'm also going to take time to go over how that works in an Active Directory environment. And I want to fill in some of the things that I remember going back a number of years in my career, like questions I had about DNS that I might not have realized I had them, but things I just didn't quite understand. Things like, I remember working at an MSP, and every once in a while we'd have a business, they'd call and they say their internet was not working. And it wasn't actually an internet issue, it became related to the domain controller being offline. And I had no idea why those things were related, or why a server going off or going offline would cause internet outage for an entire business. I remember wondering, why is it sometimes that when I'm pinging to test something, I can ping and use the fully qualified domain name, as in like computer name dot domain name, and that would work, but I couldn't ever just ping the computer name and get a response. I didn't understand why that would happen sometimes. Or sometimes it never really made sense. Why is it I can ping a device in some places, but in other places, if I try pinging the device names, it never works. So these are all just kind of questions that are like gray areas that I learned over time. I understand how all the different pieces work now, but I want to go over all that conceptual knowledge and kind of tie together from end to end, from the client perspective all the way out through the internet, and how it works through all phases, so that hopefully that fills in that picture for you so you can really understand DNS. In reality, it's not a complicated topic. This is, once you get it, it's something you'll never forget, and it's very easy to understand in any situation. It's just a matter of getting the concepts of how all those pieces are working together squared away. So with that being said, let's go ahead and take a look at DNS. Okay, so I think everybody understands out of the gate, DNS is just mapping a device name to an IP address. And anytime you're trying to check to see if DNS works, you pull up your command prompt and you type in ping, and I'm going to use the name of my domain controller. And if I get a response and I get an IP address, I know DNS is working and I have network connectivity, right? This is a one-on-one thing I think most AD or IT administrators know. Now, the thing I think people might not realize is this isn't just the way it works in your local domain. This is also basically the way it works everywhere, across any time you use a friendly name to access any network resource or any resource on the network or internet, period. So this also works exactly the same way for an internet service. If I ping google.com, I also get an IP address and get a response. Now, the first concept I want to have you understand here is this idea of what's called zones or domains. And that is basically the root of the DNS lookup you're doing. Now, google.com is a domain. It's owned by Google. For Active Directory, it's called the zones, but I'm going to refer to it as domains because that's more of a universal term. dzab.local is my Active Directory domain. So on any domain, you should be able to ping the root domain itself and get a response. We did that here with google.com. Google.com is the domain name. For Active Directory, I can ping dzab.local, which is my domain name here, and I will also get a response from the DNS server that owns that domain. This idea of ownership is important, and every domain that exists is owned by something. Publicly, domains are owned by, or who owns a domain is registered under a DNS registrar. Privately, on-prem in an Active Directory domain, the owner is going to be your domain controllers, or if you don't have Active Directory, it might be a DNS server. But this concept of ownership is going to be important, and we're going to get back to it later. Now, underneath a domain, you can have individual records. Publicly, those records are represented by subdomains. So everybody's familiar with google.com. That's kind of a universal website, right? But you also are familiar with the subdomain mail.google.com, which is Gmail, or there's also drive.google.com. Now, subdomains on the web are a little different than records and AD, but they're essentially the same thing. Now, mail.google.com, drive.google.com, calendar.google.com are all records under the google.com domain. Likewise, in a private AD environment, the subdomains or the names that exist under your root domain usually represent a number of different objects. The most common one, like we did with our very first ping ADP1, this is my domain controller. ADP1 is a record that's under my dzab.local domain. Cancel this so it stops running. If I look at the DNS for this domain, and this is where you see zones instead of domains. Zones and domains, like I said, same word. Go to dzab.local. I have client, management, and AD. These are all sub-records under dzab.local. So I can type the names of these and get a response because they're tied to records. Now, commonly, these are names of devices, but in Active Directory, you can also have like an alias of something. Like if you had a file server, but you wanted to have a generic record so you can access that file server by just files.dzab.local instead of fsserv1 or whatever the name of the server is, you can create that record. It'd be a DNS record under here. It's a DNS record under dzab.local. Obviously, with the web, you have the subdomain records as well that can point to other IP addresses. Now, this is kind of core concept under the ownership, but just to kind of reiterate, I'm going to cut over a whiteboard and let's just draw this out just for visuals. Okay, we talked about zones and we talked about subdomains or records. So let's just draw this out. Under zones, we demoed google.com. That's a public zone or a website. And then I also talked about dzab.local, which is in my lab the private Active Directory domain. Now, under a zone, you can also have records or subdomain. So here I've got drive and I've got mail. Or for dzab.local, I have my Active Directory server, right? Or I think I had also client device. I think that's a name. But first concept, you have the domain, the zone, and you have sub-records that represent something that exists underneath that zone. This is going to build the foundation of everything else that we're going to talk about with DNS and how everything works. Basically, you have to know there are zones. Those zones are owned by a server somewhere. I'm not going to talk about some of the mechanisms about the web and how that registration works beyond knowing that there is an owner of every zone, and you should be able to look up the records. So from there, we're going to go on to the next topic, which is how clients work with the DNS servers that they're assigned to get results when they're doing DNS lookups. All right, going back to my lab RDP session here. This is a Windows domain computer, and on any Windows computer, I can look up to see what my DNS server settings are by typing ipconfig all. You'll see listed here, DNS servers. I have one server. This is normally bad practice because you want two for redundancy, but in this case it's a lab environment. I only have one domain controller, so I only have one DNS server. Now, whatever server is listed here, any DNS lookup I'm doing from this computer is always going to this server to get a result. So when I ping, let's see, I think this is the name of it. Yeah, client P1, and I get an IP response back, that lookup is going to 10.0.0.4 to get a response. Now, the thing about this is, when I pinged google.com, I only have that one DNS server. That request is also going to this server to get a response. Now you'll notice, if you think about it, this is going back to one of those questions I had early in my career that I wanted to figure out, which is, if a domain controller goes down, why in some cases does that cause an internet outage in the business? And that is for exactly this reason. All DNS requests are going through whatever DNS server you have configured. So if you're a small business and you only have one domain controller, which is a bad idea, and that domain controller is configured for the DNS server for all the clients in the business, if you lose that domain controller, DNS stops working. You technically still have internet in your business because the internet itself isn't working. It's just that any DNS resolution has stopped. And you'll know that this is the case because you would be able to, if you knew the IP address of Google, you could ping that IP address, even though you wouldn't be able to ping google.com, and you'd get a response from the IP because the IP is working. It's just that you're not getting any sort of DNS lookups. So that's why this DNS server is important. The other thing that we're going to get into here is this idea of ownership. And this, I mentioned earlier, this is important. The reason this is important is because the way DNS lookups work is called a recursive lookup, meaning if I say I want to ping google.com, or I'm looking up google.com, my first question is going to go from this workstation to this DNS server, which is listed here. Now, you'll notice under my zones, I don't have a zone for google.com. So the server's thought process then is, I don't know this answer. I'm going to go to the next step in my DNS lookup chain to get an answer from someone externally. Now, the next step in that chain is one of two things. In most places, it's going to be what's called a forwarder. Now, a forwarder is literally, if I don't know the answer, or if the DNS server doesn't know the answer, the forwarder is who it looks to next. And these settings are found under the server settings. Mine's timing out here, so let's give it a second here to catch itself up. Apparently it does not want me to right click on that. So let's just do this instead. Just going to connect directly to the server because apparently going to properties is just timing out. All right, took a little while to load here, but I'm on my domain controller. Let's pull up DNS here where I can see this properties. And now if I right click on this and go to properties, under this forwarders tab, this is normally where you would have your forwarders listed. Nothing is configured here because this is a default out of the box setup. But what I could do here is edit, add a DNS server. That's Google. I believe this is the other thing for Google. I might be wrong. Let's do Cloudflare. There. So now my forwarders are Google and Cloudflare. Now, if I ping or try to do a DNS lookup from a client and this server doesn't know the answer, these are the next steps it's going to take. Now, if these aren't set, like it wasn't set in the beginning, and I can still do lookups, the way it works is it does this root hint lookup, which is literally, these are the servers that are configured for top level domain, and it does kind of a full lookup where first it checks for who owns com, once it gets those servers, it checks for who owns Google, and now it's got a chain for google.com and gets the address from that. That's a long, convoluted process. It makes DNS lookups longer, and we want to avoid that. So in most cases, you're going to see the forwarders configured. Now, these servers also might not have the answer to DNS, but as long as it exists, they will reach out and get it for us, return the response to this server, and then this server returns a response to my client. So let's switch over. I'm going to illustrate that really quick just so you can understand how that's working. Okay, to review how this DNS chain works, we have our workstation. We have our on-prem DNS server. And then from there, we've got our, let's see if I can draw a cloud for the internet. We have our external DNS server. If this workstation wants to look up a domain that this doesn't know, so let's say this is going to, we'll use a different domain. Let's say this is going to msn.com. I want to get there. The first step it's going to go is to this server. This server checks the list of domains that it knows. In this case, it's our Active Directory domain controller. The only domain that this owns is dzab.local. It doesn't know msn.com. So its next step is to use a forwarder and check and send the request on to our internet DNS. This is going to look up msn.com for us, and it's going to return the IP address to this server, which is then going to return the IP address to the client. And now I have a lookup for msn.com that went all the way out and back in, and I can resolve that domain name to its IP address. This is basically how all DNS works constantly when you're on the internet. It's always going out and back in, and DNS servers themselves are really efficient at caching results. So this might not have known where msn.com is the first time that I looked it up. However, it'll cache that result for maybe 60 minutes, maybe 10 minutes, depending on the settings of the record. And now it will constantly return that cached result back until that time to live value is gone. I'm not going to get into time to live. Just know that it caches the results to make future queries much faster. And that's why DNS is very, very efficient. The next thing we have to understand goes back to this concept of ownership. This lookup process is for domains that it doesn't know. However, if instead I am looking up not msn.com, but I'm looking up dzab.local, which is a domain that this owns, this workflow no longer takes place. Instead, I have one step. I go from this client to this server. This server owns that domain. It is going to respond. It's what's called authoritative for this domain. It owns it. So it's just going to return records. It's not going to go through this other process and do any future lookups. It says, I got this one, sends the result back. This is where things get important for DNS. I'm going to illustrate why this is important in the next clip here. So let's cut back to our remote desktop session and I'll show why. Okay, I'm back on my lab RDP, and to further illustrate this concept of authoritative versus non-authoritative or recursive lookups, I'm going to show you how this works in real life. So this is my client workstation, right? I'm going to ping msn.com, and it's going to return a public IP address for the website msn.com. Now, if I go here, I think I have to click through a bunch of Edge loading screens. All right, first time I load Edge, this took a while and I had to click through all the screens. So now that this is up, let's go to msn.com, and just like we expect, it loads the website msn.com. This is going really slow. I literally had to cut out like 30 seconds there. All right, now, what do you think is going to happen if I go to my DNS server and I add a domain for msn.com? Wait for a little bit and let you think about it. knowing the idea of this chart over here, where it goes, your lookup goes to your DNS server on-prem first, and if it doesn't know, it goes outside. If I add the domain to the DNS server, what's going to happen? Let's do it and find out. First thing, oh, there we go. All right, let's add the zone. This is going really slow. It's kind of driving me nuts. Next, next, next. All right, zone name, msn.com. So now my DNS server here in the lab has msn.com as a domain that it owns. Now I think I also need to do this. All right, it's got the domain. If I go back to my client, now I've already done a lookup here, so just for accurate results, I'm going to flush my DNS cache so I don't have any cached records. And now, if I ping msn.com, instead of responding with the public IP address of the website, I get a response of 10.0.0.4, which is the private address for my domain controller that I actually added to the zone after I created it. And if I go back here and refresh, it's kind of going to work because I have a whole bunch of cached results from the page from the first time I loaded it based on the browser. But you'll notice it's not really loading anything beyond that because it can't resolve the domain of any of the pictures or any of the dynamic content it's trying to load on the website because msn.com doesn't actually exist. Here I'm trying to go to www. Wow, it is loading. It shouldn't be able to do that. I'm very curious on how that's working. I'm also curious to see if I'm going to see a bunch of errors in the console here. Console. Oops. Yeah, there you go. See a whole bunch of failed to load resources and failures because it can't actually resolve the domain. So that's just to illustrate this point further. If you ping, if you're trying to look up a zone that your local DNS server knows and owns, it's going to respond with the records that it owns. If it doesn't know that domain, it won't respond at all. This is important now for the next bit of information we're going to get into and figure out, which is this concept of fully qualified domain names or search suffixes. This isn't really important now from an internet perspective. This is completely going to talk about on-prem stuff. But this is how device name lookups work for short names in an Active Directory environment. Now, if I, just to illustrate this, let me clear my screen. You've already seen this a couple of times, but I'm going to ping client P1, and I get a response. The subnet is, there's a firewall in the way, so I'm not getting a response from the network, but it's resolving the DNS lookup. It's going 10.0.1.11, right? Now you also notice if I ping client p1.dzab.local, I get the same response. And that's because we know this is the same record. Client P1 is a record that's in the dzab.local domain. The question is, how is it if I ping client P1 that it knows to look in dzab.local? This is an Active Directory function. If I type in ipconfig/all again, join my network settings, you will see something called a connection-specific DNS suffix. Now, this is an Azure VM. Azure VMs always have this reddog.microsoft.com suffix. This is to be expected because there's some Azure DNS stuff that Azure Virtual Machine does on the back end. However, you'll also notice under my IP configuration, my suffix search list. This is the full list. I have listed here dzab.local. What's happening here, when I type in ping client-p1, what it's actually doing is appending every domain name that you have in your DNS suffix search list. So I ping client P1, the first thing it says is, okay, look for client-p1.dzab.local, and if you find it, return the result. If I ping something that doesn't exist, ping nothing, what it's actually doing is looking for nothing.dzab.local. It doesn't find it. It looks for nothing.reddog.microsoft.com. It doesn't find that either, and comes back with it could not find host nothing. Now, just to go further and illustrate how this works exactly and how you can, if you have multiple Active Directory domains or you want to search or find and do domain name resolution across Active Directory, let's go back in here and refresh this. I have my msn.com domain, right? Let me add a record called nothing. Give it an IP address. All right. And now, if I ping this, what's going to happen? If you guessed that it wouldn't find it, you were right. Now, why did it not find it? If I look at the search suffix list, dzab.local, reddog.microsoft.com. However, I put the record in msn.com. Let's go add to our search suffix list. If I can find the options with this new UI. Properties, advanced DNS. All right. All right, so here are the two that already exist, dzab.local, reddog.microsoft.com. I don't know what switching to this does. I'm going to make sure all of the suffix lists are there so I don't break anything on the VM. Now, last thing, let's add msn.com. Okay. And now, just to confirm, now if I do ipconfig/all, I see msn.com listed here. And now, if I ping nothing, it responds with nothing.msn.com, which goes to show you, if you're using just a short friendly name, what that's doing is it's searching through your search suffix list, searching each domain for a record that exists, and then returning any matches that it has. Now, if you're working in a domain environment that has multiple domains, you can add every domain suffix, every local Active Directory domain suffix, and you can get responses from any DNS across all Active Directory domains that it can get DNS resolution from. This is really, from start to finish, the basics of DNS and how everything works. Now, looking back at my lists, the last question that I had was, why is it in some domains it seems like the devices and their DNS records populate automatically, and why is it sometimes that seems to be very intermittent whether it happens or not? The answer to this really varies from domain to domain, but realistically it all comes back to usually DHCP. If you're using an Active Directory domain environment with DNS and DHCP and they're integrated, when your device comes online to a network, it contacts DHCP for an address. DHCP will issue that device its IP address, and at the same time it issues that IP address, it will register the device's name in DNS. Now you have devices connecting, they get an IP address, they automatically get an associated DNS record, and they're good to go. There are some nuances to that setup that require this regular interval where DNS will clean up stale or expired resources. It also can cause conflicts if you have static DNS records that are referencing an IP address that some other device comes. So there's a whole bunch of maintenance things that go on with making that healthy. Now, the other thing you can do, back under the properties, you can set this with group policy. There is an option here to register the connection's address in DNS. This is checked by default, and what this will do is when a device comes online, if it's not from DHCP, it will attempt to register with the DNS server that you have specified. This doesn't always work, also comes with nuances. I'm not going to get into why that works, sometimes why it doesn't, but for the sake of the lesson here, just know that it is intermittent and does take a little bit of extra administrative maintenance just to make sure everything is working, but it's well worth it. Because once you have DNS working everywhere, you can stop trying to memorize IP addresses for machines and servers and just rely on server names, which are a lot easier to memorize and to understand what devices you're connecting to. And when you get all workstations working that way, it can also be really useful. Now, I'm just going to wrap up with a couple of final thoughts here about DNS and close out the video. There's a lot of stuff that this basics video didn't cover. It didn't cover things like record types, A, CNAME, that sort of thing. It didn't cover things like the types of DNS zones that you can host with a Microsoft DNS server. That's the kind of stuff that I am not getting into intentionally. I figure I might make a separate video for that if I end up teaching some sort of certification exam requirements that need that. But this is the stuff that isn't normally covered on the exams, but is a lot more functional. So I'm hoping it was still useful. One final point that I don't think I covered very well right near the end of that video is when you're talking about the DNS Search Suffix list, normally that's populated in one of two ways. By default, any Active Directory joined computer is going to have its domain name as a search suffix. That happens automatically. Second, if you're not on a domain computer, but then that suffix list is actually usually populated by your DHCP. When you connect to the network, you get a bunch of DHCP options that are supplied with your IP address, one of them being the default DNS search suffix. Obviously, that could be different than Active Directory domain. I think if your DHCP supplies one and you're on an AD domain that's different, you get both those lists, but I'm not exactly sure. But that's usually how those sort of things are populated to make DNS work that's supplied with DHCP. I hope you like this video. If you have any questions, if there's things I could clarify, feel free to leave me a comment. I try my best to reply. Otherwise, yeah, I might make a second DNS video about some of the basic record types and things like that, but it's not really high on my priority list. Otherwise, upcoming content, I think I'm going to start teaching about the AZ-104 exam. I think that's going to be a lot more in demand than some of the stuff I've been doing. So if you're interested in that, subscribe and get notifications as I start releasing videos. Thanks for watching, and I will see you later.